Alright guys, so if you are watching this video, it's because you're stuck on a question that is shown in the folder 6.4. So there's a few different types of questions in this folder, and they're really good questions. The first one I want to point out to you, actually a vocabulary term, and it's the word multiplicative. And multiplicative, and there you go. Woo! Multiplicative, it looks like the word multiply. That means multiplicative relationships are when you do something to the starting number or the starting information, and that something specifically means when you multiply or divide that starting information to change it into something else. So we saw things like our tables, our XY tables, our dependent independent variables, and you do something to X to our X values to get to Y. In this case, if you multiplied or divided your X by something to get to Y, it would be considered multiplicative. It is additive. It's an additive relationship if you add or subtract, and I put commas, to your X. So if you add something to your X or subtract something to your X to get your Y, that's going to be an additive relationship. You also use these words interchangeably whenever you're looking at a graph. And so when I mean graph, when you're looking at your coordinate grid, and coordinate grids are later on where we really talk about them. But just remember, when you're looking at a coordinate grid and there's points plotted, and let's just say these are the points that are plotted here. It looks like this. It crosses here. Maybe they have a line through it. Maybe they don't. I'm going to draw a line through it. But if it's right here, if it does not cross the origin, and remember, it's been a while since we've really used that vocabulary word as far as having it in problems or anything like that. But if it's not in the origin, that's that center, that's 0, where all the lines cross and meet. That's the origin. If it does not cross in the origin, it is an additive relationship. So if it's anywhere above or below the origin and does not cross the center mark right here where they cross that origin, it is additive. If it does cross, let's just draw another line. I'm just going to pretend like that's straight. Don't judge me. But if it does cross through that origin, it's multiplicative. So this would be a multiplicative relationship, and this one would be an additive, and that was meant to be an A. So just keep that in mind when you're looking at them. Also, remember, when you're building equations based off of a table or a graph, if you have just that coordinate graph right here, go ahead and do your ordered pairs. So I'm just going to do a few ordered pairs real quick. I'm going to pretend like this is one of them, this is the next one, and here's, I guess, the first one. And I'm going to make my own XY table for it. That's the first thing I should always do, so that way I know the points. And I'm going to pretend like this is on top of that origin. So the first one would be 0, 0. The next one would be 1, 1, 1, 1. The next one's going to be 2, 2. So I would look to see what the information is on my table. Then the next thing I'm going to do is I'm going to find that rule, and we're going to take it back elementary style when we think about that rule. What do you do to X to get to Y? What's happening to X to get to Y? Well, in this case, it's just times 1, and that's meant to be a multiply sign, times 1, and that rule fits in all the spots, times 1. So when I have to build my equation, remember it's X and the rule, and the rule equals Y. That's going to help you build the equation. So if you can find the rule, in our case it's times 1, our equation would be X times 1 equals Y, and that's going to fit each time. So just keep that in mind when you're finding the equation to go with the table, or if it's going with the coordinate grid. Now let me zoom out just a little bit to give myself some more room. Push this to the side just in case you're still looking at it. Okay, so you also have problems where it's asking you to find a ratio. And remember, the ratio is a comparison of two things, so you always have to make sure to write the information. So you have, I know one of them talks about calories and minutes. I don't want to set up that problem for you, but I do want to remind you, because then it asks for hours. Remember, 30 minutes, oops, let me put my pen on. 30 minutes equals half an hour. 30 minutes is half an hour. 60 minutes is 1 hour. And those are things that, by the time you're in 6th grade, you're expected to know. Just keep that in mind. And hopefully that'll help you with that part of the question. Let's see. Oopsie. Let me see if I can move this over. All right. Uh-oh. All right. So there's also where it's asking about percentages and entiles. Remember, percent is out of 100. And if they're telling you 30% of something, 40% of something, it doesn't matter. You're going to need to set up your percent tic-tac-toe. Remember, percent's always out of 100. You have your part, your whole, the number, and then your percent. And you just fill in the information that is given. Now, in these cases, let's pretend I'm given my part and my whole. Maybe it's 3/5. There's a few things you can do. You can quickly bat and ball the information, and I'm going to try to show you that real quick. Remember, multiply what's across from each other, divide by what's left. If you didn't want to bat and ball, and I'm going to just erase that real quick so that way we can use the same problem, you could find a nice little scale factor. In this case, I know, because I just know 5 times 20 is 100, so I know I can find a scale factor of times 20, and what I do to one, I have to do to the other times 20. Remember, you might be given the percentage instead, and so maybe you would bat and ball the opposite way. So use that information to help set yourself up. If you have problems where there's fractions and then percents, remember those fractions, the fractions could be set up like this. Fractions are made up of parts and wholes. This is a fraction, part and a whole, and so you can literally do the same thing, part and a whole, and then put it there, and then turn it to 100 to make it a percent, and then bat and ball. So it's really not that difficult. There's some problems where there's some percent, some fractions. Remember, we cannot compare things that are different. So if you need to take a fraction and turn it into percent, which is probably the easiest thing to do, make sure you do that. There's also a question where it's asking to convert. And it's a question that we've seen already probably like 5 times. And we saw it on a review, and we saw it on a quiz, and then a retest, and then we saw it during warm-ups. And it was a question that you guys continuously miss, and it's here on purpose because it's a really good question. And it talks about this question. It's number 12, actually, so draw your attention to it. It talks about these yards that are rushed, and then it asks you for feet. Remember, use your math chart. There are 3 feet in 1 yard, and you're going to have to do a few things first. And let me see if I can move this out of the way just a little bit so that way, whoopsie, so I have some room to write. 3 feet in 1 yard. Remember, we can use things like bigger to smaller. You multiply because you get more. Smaller to bigger, you divide because you're taking them and putting them into groups, so it'll look smaller as far as the number is concerned. So pay attention. I hope you guys remember us going over this question. We've gone over it a few times, but if you don't, remember, go ahead and set up what you do remember, what you can remember. Move on to the next question. Flip that red card, and then we'll be by to help you. Before I move on, remember, percent is out of 100. And so if you're given a grid, and we're going to pretend like this is like a hundreds grid, or maybe it's not, you need to count to see how many total are there. Use things like your arrays. You guys know you can set up an array, and I'm just going to pretend like it's like 1, 2, 3, 4, 5 here, and 1, 2, 3, 4 here. So 5 times 4 is 20, so it's out of 20. And then I would have to turn it into 100 if it's looking for percent. I am just giving you that as a hint, because if it asks you for the difference of the shaded portions and it's asking for it in percents, you need to know the difference. You need to turn them into percents and then subtract, because difference means subtract. All right, do the best you can. Set up that card whenever you need to. Ask your shoulder partner. Don't waste time because this is time to really prepare you for that STAR test.